Welcome to the last breakout of the conference, but definitely not the last event, so stick around. I was gonna say welcome on stage, my friends, but they're already on stage. So here we have Chris, Brian, and Shelby to talk about shredding the slopes. That's it.
Thank you.
Thank you, Flo.
Clap for myself.
Good afternoon, and welcome to Shredding the Slopes with Statistics. We're going to show you how Boyne Resorts built custom models to forecast skier visits. My name is Chris Wolman. I'm the lead report analyst at Boyne Resorts. I've been in the ski industry for 29 years, and I love snowboarding under a bluebird sky. Nothing better. I've been at Domopalooza. I'm at Domopalooza. I've been a major Domo since 2017, and I've implemented Domo for 2 different resort corporations. Today, I'm joined by 2 extraordinary people from the Domo AI Labs team, Shelby McNeill and Brian Powell. Would you like to introduce yourselves?
Yeah. Hello, everyone. My name's Shelby. I've been on the data science team for 2 years here at Domo. I'm excited to be among people who like numbers like me and are potentially as socially awkward and introverted as me, so thank you all for coming. We can all hide in a closet later from all the extroverts. But no, I'm genuinely excited to be here. Why Brian and I are here today with Boyne Resorts is because we work on the AI Labs team, and many of you may know that we offer consulting to clients who want help with any kind of data science, machine learning, AI solution. So that can be anything from just like office hours to helping with a full solution, like we've done here with Boyne. And we're happy to be here to talk about Boyne's solution because they're one of our best customers. They've got great data, they've got a great use case, and my favorite thing is that they very much bought into what data science is. It's a long-term process. So we've been working on what we're about to show you for 2 years now and counting. And so we're excited to show off that work today.
Awesome. Yeah, and I'm Brian Powell, an associate data scientist on our AI Labs team. I've been with the team for about 3 years. Also very happy that we're in a safe space for introverts. So I'd also like to point out, although you can see me in ski gear there are no skis on my feet. I am at the bottom of a hill. I'm not like Chris over here at the top of a hill on a snowboard, but very fun project. Really enjoyed working with Boyne. We're excited to share this with you.
Okay, we're going to start with the key takeaways for this session. The first one is to create an end-to-end data science and machine learning solution all in Domo. We're going to use Jupyter Workspaces to build and deploy custom forecasting models. And finally, we'll monitor model performance and the data pipelines using automated dashboards and alerts. Who is Boyne Resorts? Boyne Resorts is the 3rd largest mountain resort company in North America. It was founded in 1947. Boyne owns 10 ski resorts and 14 golf courses across the US and Canada. Some of the resorts are Brighton here in Utah, just outside of Salt Lake City, Big Sky in Montana, Sugarloaf and Sunday River in Maine, Boyne Mountain in the Highlands of Michigan, Cypress Mountain in British Columbia. Boyne has been a Domo customer since 2020. So Boyne's $1 million question is, can't even see it, how many staff do we need next week? And to help us answer that, we need to know what services we have to provide. And ultimately, that comes from knowing how many skiers are coming to our resort. Once we know how many skiers are coming, it lets us make decisions like how many lifts do we need to operate? How many food, retail, rental locations do we have to open? So that's why we chose this. It's the foundation of everything we want to build off of with this question. Why did we choose Domo? We chose Domo because we could build the entire solution in one place, in our Domo instance. We didn't have to have it in multiple locations, different tool sets. It also gave us the ability to partner with the Domo's AI Labs teams for assistance. You know, they have a great data science team. We don't have data scientists, so we're leveraging all their knowledge and expertise to help us get a great return on this project. What is the solution? It's a fully automated 10-day forecast of daily skiers for each of our resorts. The forecast takes into consideration historical trends in skier visits, weather, number of tickets purchased in advance, holidays, and even more. We can't share all of our secrets, but give you an idea. There's a lot going on that it looks at. We built 2 Domo dashboards for this solution. The first one displays the actual skier visit forecast, and the second dashboard reports the accuracy of those forecasts. We're going to show you both of those dashboards today. Please note the forecast will only be for a couple of resorts, and we have altered the data for privacy reasons. With that, we're going to go over to the demo, please. So we're starting with the 10-day skier visit forecast dashboard. This is available to our Boyne executives and also all of the resort management teams. The first line chart we see here at the top of the dashboard, this gives us the skier visit forecast for each resort and for each day for the upcoming 10 days. We update our forecast every 3 hours between 6 a.m. and 9 p.m. Eastern. So in this box here, on this card, we can see the time the forecast last ran. We update the forecast frequently so that we can adjust the predictions and always have it based on the latest sales and weather data as it's coming in. The next section of the dashboard allows us to select a single resort and focus in on the details. So we'll pick Boyne Mountain in this case. What we see is a line chart showing us the skier visit forecast, and it also includes the forecast range in dark blue. So the range is establishing the upper and lower bounds of the forecast. So when we're trying to schedule at a resort, how much staff do we need? How many people are coming? We'd love to say this prediction model is perfect and it knows exactly to the skier how many are going to be there, but that rarely happens. So being able to provide a range to those operations, they can say, okay, we're going to have this volume within that range. And the model is establishing that range. It's not something that we are doing. So it helps for logistics planning. Below that, we have a table which is showing several of the factors that are influencing the forecast. So we can see the number of tickets booked for a day, if the date's a weekend or a holiday, will it be snowing or is there sun forecasted? Gives people a little insight into how's it coming up with the numbers, right? It's not all magic, as everybody likes to think. When working with forecasting data, most common thing people want to know is, okay, you're giving us a forecast. How's that forecast doing? How many skiers actually did come? Is it working? So this first chart shows us again our forecast and the range in blue, and then you can see the red is the actual total skier visits that occurred on that day. Below this we have a table which is highlighting, did the actual skier visits actually fall between our high and low estimates? So obviously we like to see more yeses than nos when it comes to that. The last part of this dashboard, which is an important part, is our data flow pipeline monitoring. So this card has a list of all the data flows that power this solution, the time it was last run, the hours since the last run, and if it needs attention. So if a data flow doesn't run within 3 hours, the needs attention column will equal 1, and you'll see the row get highlighted, just like in our example here. This also sends us a Domo alert that says, hey, something's not working, go take a look. So it's a really simple card, but it is essential for continuous monitoring and peace of mind that our solution's working as it should. Next, we'd like to share with you the accuracy dashboard. So the accuracy dashboard is used by the Boyne analytics team, and this is where we can look at and assess how's this doing. How, more information behind the scenes that our business users would just be overwhelmed with and start to get lost in the weeds. But it's really important to us as we want to iterate on this and make it better and better every opportunity we have. So we have a number of filters available, such as choosing a single resort, day of the week, and days out. So something we did a little different, instead of using a simple univariate time series model, we created 10 individual models with several predictors. So each day leading up to the prediction date is its own model. So we can independently look at the performance of each day and adjust those models if we need to. The stars of this dashboard are the metrics used to assess the accuracy. So we'll start off, we have MAE, which is the mean absolute error. This tells us how far off the forecast is on average. And MAPE is the mean absolute percent error. This is a scaled version of the MAE. So as we're looking at Big Sky here, we can see we have an overall MAE of 670 skiers and an MAPE of 11%. So you could interpret that as, on average, we're off by 670 skier visits. Not too bad. The next chart shows us the comparison, what was the actual versus the predicted. And below that, we see the individual performance of each of the 10 models, one for each day, MAE and MAPE. We also look at the percent within prediction bounds below that, which that's just telling us how often we're falling within that predicted range. The last section of this dashboard allows us to look at all the same metrics by days of the week, sorry. So we can look at how's a Sunday performing against a Monday or a Saturday, which is very interesting for us to look at as well. If we could go back to the presentation. Perfect. So before and after the solution, we have no more last-minute guessing. Our forecasts are available 10 days in advance instead of somebody saying, oh, it's 2 days out, well, what's our plan? So that's the goal here, is to give people more information sooner and have it be as accurate as 2 days out. We have no more lost spreadsheets because the person doing the forecast lost it, or dependency on one person at a resort who knows how to forecast, right? People move on to different jobs or take different positions, and all of a sudden, oh, this guy's been doing it for 20 years. He just moved up the chain, and now we have a gap. So we're trying to fill that gap by having all these forecasts created using the custom models, and then all of this information is available via Domo dashboards to our users. Now we're going to talk about building the solution. And so at this time, I'd like to turn the presentation over to Brian to give you all the goodness of what they did to help us out.
Fantastic. Thanks, Chris.
Sure.
So now that we've seen that fantastic demo of the solution, we want to give you a little bit of a peek behind the curtain as to what exactly it took to build this solution for Boyne and the steps that we took to do that. So as part of the Domo AI Labs team, as Shelby mentioned earlier, we get to work with a lot of customers and get to work with a lot of really interesting use cases in different industries. And they're all a lot of fun. Gotta say, shredding the slopes is definitely up there on the list, a lot of fun. But although we do touch a lot of different industries, we follow a pretty similar process. That process is what we're gonna share with you today, this step-by-step across the top here. We're gonna dive into each of these steps. It's also a bit of an iterative process. So we'll show you the first round of modeling that we did for this. And as Shelby mentioned, we're on our second season now, and she'll be sharing with you the second iteration of the model and how we've improved on it as well. So let's dive in on that prepare phase. So in the prepare phase, we begin by defining our business problem and defining a business question that is very specific. We don't necessarily just want to say how many people are going to visit our ski resort, right? We want to say, how many people will visit this very specific ski resort, perhaps Big Sky Resort, on a given day, right? And that also, you notice that Chris was pointing out total skier visits, not necessarily just skier visits. The total includes icon passes, mountain collective passes, season passes for an individual resort, and just people that show up at the gate on a given day. So we defined that specifically. We want to look at the total of skier visits on a given day at a specific resort. Once we've defined that, that becomes our outcome. And we want to figure out what exactly affects that outcome. What data do we need to be able to answer that question? So you can see here, what we do is we build what we call a conceptual model. In this conceptual model, we don't want to restrict ourselves to just the data that we know we have in our databases, what's easy to get, things like that. We want to really expand what might actually affect how many people are coming to visit. So we, on our team, we call it blue sky thinking, out of the box. We were really just thinking about anything that might affect it. So you can see some of those listed here. Boyne has some destination resorts that take lodging reservations. So those were one of the things that we thought might affect it. Obviously, how many people purchase a ticket for a given day in advance of that was a big factor. Another is school breaks. We've got spring break going across the country in a lot of places right now, so that's something we thought might affect it, and any other holiday. So those are a lot of examples. Another was here in Utah specifically, we've got Boyne Resort, and that canyon can kind of become perilous during like a big snow event, something like that, and the traffic can get shut down. So that was something that we thought, well, obviously that would really affect whether we have the resort open or not. And that, in the next step, we found was something that's a little more difficult to get in advance information about. So we start with that conceptual model and say anything that might affect the outcome. Jump to the next step, and this is where we ground a lot of that and say, okay, we know what we want to have in a perfect world to understand the outcome. What do we actually have access to? What are other things that we could get access to if we wanted to add them into our model? So in this part of the process, that one example that I just gave of the canyon shutting down and nobody being able to get to our resort, that's something we might not know until the day of or 2 days before. If we could model that, that would be an incredible model as well. But that's something that's a little bit more difficult to gather. So in this part of the process, we kind of funnel down to those that we know we have access to. We point out where they are in our database, and they may be spread across different data sets at different levels. And so we need to find a way to get those data sets together. We write down the data sets and the variable names we're looking for, and how we might join those together in this part of the process called a metric map. So from there, what we found when we did our metric map was that Boyne had a lot of really good data and a lot of really interesting data, but a lot of the columns we were looking at, we only had 2 years worth of data rather than more than that. So a really common model that data scientists use in a time series problem like this is a time series forecast, like an ARIMA or an ETS model, something like that. However, for best practice, it's really important that you have at least 3 cycles worth of data to be able to run a time series forecast like that. So as part of that metric map, we also found, well, we've found that at this point, we may be restricted in the type of modeling we're able to do. So we decided to move forward with a regression-based model. As Chris pointed out, we've got individual models for each day leading up to the date of interest. So we've got a day 10 model, 9, 8, all the way to the day before people are visiting the resort. And you can see here it might be very small, but I can read it for you. We've got snow actual forecast 1 day, 2 day, 3 day. And so each one of those columns we want to use as predictors. We created an iteration of that for each model that we wanted to build for each day out. So a lot of that really important preparation takes place in conceptually thinking about it, grounding that, and then actually gathering that data into one consolidated data set we can model on. Next, we run into our analyze phase. This is where after we've understood what data we have available, we really want to get to understand our data and know what's happening with our data and what the relationships are within our data. What we do is we work with a lot of different cards in Domo here. You can see that we've got a correlation matrix that allows us to understand the strength of the relationship between our outcome, how many people are coming to the resort, and the predictors that we have. We can also analyze the strength of the relationship between the predictors themselves. And then you can see we've built out histograms to understand the distributions, scatter plots to understand, again, one other view of just how strong those relationships are with the outcome, and then box plots to understand how different categories work with each other. And you can see in that box plot we used a non-holiday weekend, non-holiday weekend versus a weekend or holiday. With that, we made sure, even though we couldn't do a time series forecast, that we took elements of time into our model that was regression-based. So we took like a lag that said, okay, what happened 1 week ago things like that, and then also took into account whether there was a holiday or a weekend or a weekday happening. So once we've really got to understand the data that we have, we can move on to that modeling phase. And in the modeling phase, we want to bring as many predictors in as we can. It's kind of like taking a quiver of arrows. The more arrows you have to shoot at your target, like me, I'm terrible with archery, so I'm not going to hit the target unless I've got a ton of arrows. So we want to bring as many predictors as we can to that phase so that we can find the ones that are going to combine to create a good model that is accurate. So in the modeling phase, Domo actually is fantastic for this whole process we're looking at here. Shelby's going to talk to us about how to productionize this and how we made this an automated solution. But Domo's nice because you can do a lot of that preparation work, EDA, as well as this modeling, all in one place. And I'm sure a lot of you have good experience with Domo in that way, just that it's a tool that does a lot for you. So one of our favorite tools is Jupyter Workspaces here, and I want to show you a little bit about it if we could switch over. So many of you might be familiar with Jupyter Workspaces and used it, and many of you may not be, but this is the page for Jupyter Workspaces, and we're going to take a look at one individual workspace here. The nice thing about Jupyter Workspaces is it's a development section of Domo, where you can develop these models, you can create visualizations to understand your data better, and the nice thing is that it is interconnected across Domo. You bring all your Domo data sets in, you can read those in, you can do whatever you want with them, and then you can write data sets back out to Domo and have those available in Domo so that you can create visualizations and cards for business users or to communicate with your team. So in the configuration of this space, we decide whether we want to use R or Python programming to build our models. We decide what tier of compute we want there and the amount of time we want that to run. We also connect any input data sets that we've got in our Domo data warehouse. And then in this section, you can add new output data sets. So these are not output data sets that already exist in Domo. These are ones that you're going to say, I'll add one and name it myself, whatever I want it to be. And then you'll be able to write that out to your Domo warehouse. So let's jump over here. And this is the actual Jupyter Workspaces. This is where you can code the models. This is where we built ours. And you can schedule this as a data flow, just like any Magic ETL, to run on a schedule or to run on a trigger event. If you have a data set that's feeding this, you can run it just like a Magic ETL when that's been updated. All right, and with that, now that we've looked at that modeling phase, we'll pass it over to Shelby to talk about how to make a pipeline.
Yeah, thanks, Brian.
Yeah.
So if we can head back to our slide deck, thank you. So after the modeling phase, we chose the best model that was giving the best results based on the data that we had, and that was a linear regression model. When I say model, just think an equation that's going to say, okay, times all these predictors together, and your output is how many skier visits. So once we have that equation that is going to predict skier visits, we have to build what's called a model pipeline, or like sometimes we call it productionizing a model pipeline. And in general, what that means is it looks like this. So we've got to take our data, we've got to hook it up to the model so that the model can digest the data and figure out what to predict. The model's got to spit out our predictions, and then we've got to have a way to take those predictions and be able to visualize them, disseminate them to stakeholders, and then we need to be able to assess their accuracy. And if it's a really great pipeline, we really want this pipeline to be completely monitored and automated so that I don't have to do anything. I just set this and it runs. So if you don't have Domo, doing this pipeline may take 2, 3, 4 softwares, platforms. You're doing each of these stages in a different software. And it's a nightmare. Like, it doesn't make our jobs fun as data scientists. So the great thing about Domo is that you can do it all in Domo. So to use the example of Boyne, like Brian said, we had our data set that had all of our predictors and features in our data warehouse. You can automatically input that data into Jupyter where our model was, as you saw. That model's going to output our predictions right back straight into our Domo data warehouse, and we can schedule that with a data flow. And then, like you typically do, we've got our predictions in Domo, so now we can just build a dashboard to display those predictions how we want, compare them to actual skier visits, and then assess the accuracy very easily. Again, the great thing too about Domo is that it's automated and it's monitored. So like Chris said, we've got our card going, so I know instantly when it breaks, and I can go fix it. If I can take a second here, this is one of the best things about Domo. I'm not a salesperson, like that would be terrible. Like, I'm gonna be honest. Some Domo data science products are better than others, and maybe I shouldn't say that out loud, but this makes Domo amazing. Like, this ability to run this pipeline easily is great. I don't know if you did the math, but we've got 10 ski resorts, and we've got 10 days that we're predicting. We have productionized for Boyne 10 times 10, 100 models for them using this pipeline, and it's seamless. I know instantly when anything breaks, and I've got confidence that it's just going to keep running as long as we want it to. So if you want to make your data scientists happy, do this in Domo. So that's our pipeline. So as I mentioned, once you've got your pipeline up and running, you just go from there. So when we had that all up and running, we entered what we call the deploy phase, which is where we launch the solution to stakeholders. So the great thing that I mentioned about Boyne is that they've very much bought into this solution, and they're in it for the long haul. So for V1 that we just talked through, they didn't choose to actually launch these dashboards and models to all of their big stakeholders, just in case it like blew up, which is actually like a really good thing, because when you train and test a model, you get an idea for how it's going to perform, but until you productionize it and actually start predicting for this upcoming ski season, you don't know how well it's going to go. So I'm grateful to the Boyne team that we kind of did a beta launch to just their analytics team, Chris, Seth, Michael, to see how it performed during winter 2022 and spring 2023. And thankfully, the models performed as expected, right, Chris?
Yes, they did.
Yes. So thankfully, we didn't embarrass ourselves. But at the end of the ski season, we entered our last phase of the data science process, and that's the assess phase. And it's what it sounds like. It's analyzing and seeing how well did our models perform. Were they as accurate as we thought they would be when we built them originally? Where can we make improvements? And so with Boyne, when we were thinking about, okay, for V2, how do we make this better? We thought the biggest bang for our buck was just going to come from having an additional year of data. So as I talked about, when we finish this ski season, we've got one more year of data, so we're up to 3 years of data for Boyne. And when you have 3 years of data in general, you can build what I'll call more advanced forecasting models. And so we thought, okay, this year we're going to try to build a bigger, fancier equation and see how it does. So we start this process all over again in the summer and fall of 2023. We went back into Jupyter, like you all saw previously with V1, and we built a new set of models. And the important thing here is that we didn't just say, okay, let's just pull out our best, scariest equation and assume it's going to have the best results, right? We tested these new equations or models against what we used previously, what I'll call our V1 models. Because if it's not broken, why fix it? Just because it's fancier, it doesn't mean it's better. So thankfully, we did find that when we tested these alternate, more advanced forecasting models, we did get more accurate results. And we did that by comparing the MAE and the MAPE that Chris showed you earlier in those dashboards. And so that's how we knew, okay, maybe this equation is going to be better for the upcoming year. So we picked a new model specifically called Dynamic Harmonic Regression Model with Predictive Features. That's quite a mouthful. It's also quite an equation. But that's what we chose to deploy for this year. Now, the great thing about this is that when you do a V2 or a V3, it's really easy to redeploy a model. It's much less work the second or third time around because you've already got your pipeline infrastructure built. So to show you here, we've essentially got the same data, but we wanted to run a new model. So we just hooked up our new dynamic harmonic regression model to run, already in the pipeline. We decided, hey, let's run it a little less frequently. We don't need to be running it every hour. So we easily changed the data flow to just run every 3 hours. And then as you all know, when it came to the dashboards, it was like, those are pretty good. We'll just use them again. So we were able to easily just copy the dashboards, make what tweaks we wanted, and there we go. We had our predictive dashboard and our accuracy dashboard ready to go for V2. That brings us to the deploy phase, which is the phase that we are actually currently in right now. So as I mentioned, V2 we have deployed for this ski season. I think we've had one resort close, right?
Yep.
But we're still waiting on some other resorts to close in April. So we're still actively using, oh, I went too far, sorry. We're still actively using V2 right now, testing it out. This year we did launch V2 to all of the C-suite at Boyne and leadership at the resorts. They've been really great at providing feedback. I know that in May, when the ski resorts close, we're going to get a ton of feedback on what we can improve for next year. And it's been really great to already hear feedback from these stakeholders. One resort was like, hey, we're kind of weird, and this situation happens at our resort, and we don't think you're taking that into account in our model. And they were right. We weren't taking it into account in their model. And so just getting that feedback from them, V3, we're going to find a variable, hopefully, and be able to account for that next year. So as I kind of previewed already, we're planning to start on V3 this summer. We'll just, keep iterating. Because with data science, it's never really done. You can't just do this once and be like, yes, 100% accuracy. Like, that's just not realistic. Like, this is a long-term process, and so we are seeing improvements each year, and we're hoping to continue to do that as we keep going into V3. So now that we've said all of that, I know some of you are probably thinking, like, wow, that was a lot. Like, that's 2 years worth of work. That's a lot of hours. That's a lot of time. Is that even worth the money? Like, how accurate was that? So to give you that answer, Chris is going to talk about, has this solution been worth the investment? And I want you to know that I told him he could answer this honestly in front of all of you. But I did remind him that I know the code for his 100 models. So it may not be totally honest, but we'll see. Go ahead, Chris.
Thank you, Shelby. What I'd like to point out before I wrap it up and answer the cliffhanging question, was it worth it? Partnering with Domo's AI Labs team enabled us, we're a small team administering Domo at Boyne Resorts, right? Large organization, we have 3 people on the team. So we're doing the best. We have our backlog, our projects. We don't have a data scientist on staff. And that was the great thing about Domo and being able to leverage their expertise. They will walk you through every step of that process, and they will involve you as much or as little as you want to be involved. We were very hands-on on the data and helping get it cleaned up. We were acquiring data. We kind of threw the kitchen sink at them. We're like, here's website views. Here's how many people look at the trail maps. All of this has to mean something. And they worked it through, and no, yes, yes, yes. And then even when we got into the models, I don't know what that super powerful equation is behind that dynamic harmonic regression model, but they do, and they know how to recommend it. And they taught us what these things were, because we want to know and we want to increase our knowledge. And as Domo's offering all these new AI offerings, I think it's helped for us to have this better understanding and how these pre-built models they're coming out with might fit in where we can deploy solutions on our own and our team has learned. So I'd just like to point that out. It's a really great partnership with their team. Encourage you to do it if you can. So was the solution worth the investment? Yes, it is. It's been a long-term journey. You know, we'll be going on the 3rd year. It's getting better every year. And it's helping to answer that million-dollar question, how many staff do we need next week, right? If we can have a 1% savings in labor for more efficient staffing at our resorts, it covers the cost of this whole solution. So that's a great return. You know, we have many resorts. You know, the buy-in comes in different stages. It's like anybody else with a large organization. Just because one place does it, the other one's a little skeptical. But we're all going to get there, and we expect to see even greater returns starting next year. I'd like to just go over the key takeaways again for this session. It was to create an end-to-end data science and machine learning solution, all in Domo. Use Jupyter Workspaces to build and deploy custom forecasting models. And then finally, monitor model performance and data pipelines using automated dashboards and alerts. This concludes our session. We'd like to thank you all for attending, and we're happy to answer any questions you may have at this time. Good job.
Yeah. You go ahead and pick, Chris.
I can't.
Am I on?
Oh,
right on. Cool. Thank you so much for sharing this. We just did a really similar thing for a client in the restaurant space. So we predicted net sales over the next 14 days so they could also schedule labor. Loved seeing your solution because it's similar to what we did, so we feel better about ourselves now. But also, the step we haven't really got to is, so we're saying over 400 locations, we think you'll do this in sales, so you should staff this many people. But we don't necessarily have a lot of why in that. So skiers, for example, do you kind of have a why of levers you might be able to pull to influence what is getting people there, or to say, on this day it was because of weather, or on this day it was because it was spring break, or different things like that?
Well, one thing that we did do to allow that to come forth a little bit more in our models was we used that linear regression approach on that first model. A lot of the time with data science, I think data scientists are pushed to go on the bleeding edge of the most complicated model they can find, and often it results in a black box model that nobody can understand, but hey, it gets me really accurate predictions. So honestly, just to kind of get a roundabout answer there, starting out with that linear regression helped us to understand exactly what are those levers with a simpler model and a simpler formula. I think the strongest predictor that we ended up with was kind of obvious. It was the number of tickets that were purchased for a given day. And then that is something that happens often, but we did find, yes, that holidays and weekends, things like that, were very strong levers as well. So I think, again, roundabout answer, but the best way to go about it is sometimes to find a simpler model so that you can discover those levers a little bit more.
I think just to build on that, the advanced tickets, right, we know who bought for what date, so that's the easy part. The hard part is the people who have a season pass product or an icon product, they don't tell you what day they're coming. They just come when they want. They're the ones who are being influenced by the weather, right? They can come multiple times, or they've bought a multi-use product. So that's who we're really trying to get the edge on. So in that model, we do have very specific features that were engineered that look at how many people came with the season pass in the last 7 days, how many came in the last 14 days, to help make that. And that's why we use these extra predictions to help influence that. And so every industry is going to be a little different on what your predictors are, and we're still working through that. And that's where, like Shelby pointed out, the one resort that hey, we have this issue, it's not in your model. Oh, we didn't know about it, but we'll get that in there next year to improve yours. Yes.
Yeah. Thank you very much for your excellent presentation. Oh, sorry, I'll be here. Yeah, like the mic. So it's actually a good segue to my question. In both your regression models, and when you started with your variables, did you notice any non-linear trends? And if so, would these two types of regression take care of that? And have you experimented, say, with an ensemble of machine learning methods or the meta-profit methods that would take care of these non-linear trends? And perhaps the harmonic one works just fine. So just my question. Thank you.
Yeah, I could speak to that. So I don't think at this time we have any nonlinear relationships in our models. We didn't find those to be the case. But I mean, if that's the case for your data, you can totally add that into a model. What he's talking about is you can interact variables together to look at like curvy lines and not just straight lines. And so that's something that we can definitely do in a model. We just didn't do it in Boyne's case because we didn't find that to be helpful. I will say too that your second question about did we try like an ensemble or something like that, when we built these models in Jupyter during that modeling phase, we typically try out probably 100, 200 different models, and that's not an exaggeration. We're trying out different equations, and we're also trying out different, making adjustments to those equations with things called parameters. And so we don't just try one model and be like, that looks good. Like, we try a whole ton. So in our case, we did try some ensemble models, and they didn't do better than the dynamic harmonic regression. In V3, maybe they will, and we'll do that. But for now, we're just sticking with the regression. Thanks.
Hi, quick question. So I was just curious, whenever you guys got to like that third year of data, did you try some time series models to see if like how that compared? I was just curious how that kind of panned out, or if you found that just like using the sort of like pseudo time variables in the linear model just sort of seemed to do the trick and didn't bother with it too much.
Yeah, great question. So we tried that during V2. Boyne has number of ski visits back how many years?
I think we pulled like 10, 15 years worth of
10,
data
15 years. And we did what you described of just running a univariate forecast. That's where you don't have any predictors like weather, number of tickets bought. It's just literally looking at trends in your visits over time. And we ran that with 10 or 15 years of data. We tried chunking it up and let's get rid of COVID, because COVID was just really weird. And when we chunked up all these different years, we didn't find that it did better, to be honest. It actually did quite a bit worse, which I found a little bit surprising. But that just reiterated to us how good their predictive data was. Especially the weather data. I mean, as you just know from skiing, weather matters. And you can't take that into consideration in a univariate model. So that's why we think the predictive model, even though it had less years of data, performed better.
I had two questions for you. The first one was, you mentioned that you assess at the end of the year for the previous year. Why wouldn't you assess each day at the end of the day? I'm curious.
I can answer that. So we do assess multiple times. Us on the analytics team at Boyne, we're looking at it more frequently than anyone. But Shelby, you can correct me if I'm wrong. You don't want to have a knee-jerk reaction, right? Because just because you're having a bad trend at the time doesn't mean the model's wrong, right? Maybe you need to re-engineer a feature. A perfect example for us, weather was really bad this year. Coast to coast, in the west, we weren't getting snow early. In the east, we had floods up in Maine. And so that affected, our models were predicting higher because they were lower because there was less ticket sales, but it's still expected, well, all these season pass people are going to come. And so we had a rocky start. And everybody understood why. And so the feedback was the model's going to get better. We have this data now in the model where it can start to identify that trend, and it will learn. That is the point of the machine learning. But the point is we don't want to go in there and just, oh, quick, change that model on the fly. Because once we got snow, once levels returned to normal at the resorts, those predictions did start coming into line and were better for the rest of the season. So yes, we're assessing, but we're assessing at a different level. We would get together and we'd meet and have a call after each holiday period. Okay, how are we doing up to this point? What do we see? And we did make some minor tweaks here or there on a couple of the models for a couple different resorts for some nuances we saw. But at the end of the year, we do that full assessment. And that's where we'll say, do we look at a different type of model? Do we engineer a new feature? Is there another data point that we began collecting that now we want to introduce that will help? Because that was part of it too. There's things we know that can affect or help the model be better, but we didn't have the data yet. So we started collecting it, and now we'll have 2 years worth of data where we can include that. So that's why the V3, and it really is very iterative because we weren't perfect right out of the gate. And so,
Thank you.
Sorry to cut you off. We are over time. So I do want to note, the data science team, we're actually here in full, I think, at this session. All of our team members. If you have other questions, stick around. We're happy to talk to you rather than go to the general session. Introverts unite. So Boyne may stick around too. I won't speak for them. But come ask us questions. We're happy to talk to you all. Thanks, guys.
Thank you.